Hey guys, on today's video I'm going to show you how I set my Z offset on my printers. Recently I've been getting a lot of questions regarding Z offset and thought that I would make this video to help demystify the whole process. So before we get started guys, if you're new to the channel, consider subscribing, turn on your notification bell, and leave some comments. I love reading the comments. I do my best to respond to them as soon as I see them. If you enjoy this video, give it a thumbs up. I put together this checklist and it's broken down into three segments. The first parts have to do with mechanical verifications, and we'll go over this in detail on the printer. The second part has to do with the software on the printer and also in the slicer. And finally, the test print. So let's jump over to the printer. We'll go over the mechanical bits and then we'll continue with software and test print. To check your wheels, all you're doing is using your finger and just lightly trying to move them. And you don't need two fingers, you just do it with one. If it freewheels at all, then you need to adjust the concentric nut. One on this inside wheel and one on this side inside wheel. And just turn them about 1/8 of a turn at a time until the loose wheels no longer spin. You don't want to tighten this too much because you don't want to dig the wheel into the rail, because this will prematurely wear out your wheels. You also want to make sure that your gantry wheels are also not freewheeling and that your hot end assembly is not loose. So you want to try to move this up and down, and if it moves up and down, then you got to adjust this bottom wheel. Same thing, it has a concentric nut right here. So all you need to do is use your wrench and get under there and do the same thing. Another thing that you want to verify is that the belts for the X gantry is sufficiently tense. And what you can do is you don't want this to be overly tight. But the best way that I found to tighten it is move your hot end back and forth. And what you don't want to see is you don't want to see the belt bounce when you move it back and forth. If the belt bounces up and down, then you don't have enough tension on it. And I'll show you, I'll loosen it so I can show you what I mean by bouncing up and down looks like. So I'm going to move the hot end side to side. You see how the belt is bouncing up and down inside of that rail? You don't want that bouncing. You'll also see it bouncing in here. That's too loose. So what you do is you just tighten it up a little bit at a time and then move it till that bouncing goes away. See, it's still bouncing a little bit. And that's it right there. You can verify the tension on the bottom. Just touch it with your finger. And it doesn't need to be tight like a guitar string, because if it is, you'll prematurely wear out your stepper motor, so you don't want that. So just a little tension. So now when I go back and forth, you can see that it moves, but it's not bouncing up and down. Same thing with the X, I mean the Y. So with the Y, you would move your build plate forward and back. And what you're looking for here is the belt bouncing up and down. You can see the belt is not bouncing. So that means the tension on the Y is also set properly. Next thing you need to verify is that the gantry is square with the frame. Get yourself a ruler. And I like using a metric ruler, but you can use a regular inch ruler as well. Place it up against the gantry. And I currently have the stepper motors off. And what I'm going to do is I'm going to use the lead screw. I'm just going to turn it by hand because my stepper motors are off right now. And I'm going to lower this till I get till I get to some kind of an even number. In this case, it's 10.5, so it's exactly 10.5 on this side. Now what I'm going to do is move the ruler over to the other side. And what you want to verify is that it also is 10.5, so you can see it's also 10.5. And where you want to place the base of the ruler is directly on the frame, just like that. Once that's confirmed, we're going to home the printer. And then we're going to verify our bed tramming. To do that in Miguel's firmware, so this is Miguel's professional firmware, you're going to go to Prepare, Bed Tramming, and Tramming Wizard. And once we initiate that, the printhead is going to probe the outermost points of the bed mesh. And as it probes, it's going to display the results on the screen. And it's going to give you a result. I've already leveled my corners, so I really don't need to do anything else. But if you wanted to get crazy, you can keep playing around with this till all these hit 0. And once they're all 0, that's essentially perfect. This is good enough for me, so I'm going to leave it. Next thing that's very important is to check to make sure that your bed probe isn't too far away from your nozzle. What I mean by that is your Z offset is not too great. From the main menu, you're going to go to Advanced. You're going to go to Probe Settings. Scroll down. Deploy the Z probe. What that's going to do is it's going to drop the probe down. What we're going to do next is go back to the main menu, Prepare, Move Axis. You want to check the box that says Live Move. And then you want to move the Z axis. So now I have it selected. As I rotate this knob, it's going to lower the gantry, and I'm going to show you exactly what you want, what you're looking for. And this is how you verify that your Z offset is not too great. What I've done here is I've 3D printed a little spacer here, and I'll include this STL file in the video description so you guys can use it. And I'm going to put this underneath my nozzle because I don't want my nozzle to get too close to the bed. I don't want it hitting the bed. I want to stop it slightly before it hits the bed. I'm just going to put that under there, and I'm going to start to lower my Z. So you can see the printhead is coming down. And if you guys notice right now the probe, see how the probe is right now making contact with the build plate? But just because it's touching the build plate doesn't necessarily mean that it's triggered. It's currently not triggered yet. To trigger it, you need to continue to lower it. So I'm going to lower it just one step at a time. And what you want to try to determine is how far of a gap you have between the trigger point and the nozzle. So right now the nozzle is almost on top of that little 0.5 millimeter part that I printed, and I'm going to continue to go down, and you'll notice that the probe is going to change color from blue to red. Oh, and it may even retract. If you lower it real slow, you'll get to a point to where it's kind of going between red and black, or red and blue. And then if you go one more below that, it's actually going to trigger it. So right there. So I just triggered it right there. So this space right now between the nozzle and the bed is the Z offset. So that's currently the Z offset. And this 0.5 millimeter part helps me get it close to the final Z offset. Now the final Z offset is going to be determined by the amount of squish needed to get a good first layer. All right, so once you verified that this is okay, then the next thing we're going to do is we're going to build a mesh. If, for example, your probe has triggered, but you have like 1.5 millimeter gap between the nozzle and the bed, then what you need to do is remix your CR touch bracket so that the probe can be moved up some more. So by moving the probe's position up, that's going to decrease your Z offset. It's kind of confusing, but think about it as if the probe is the entire CR touch physically, the body of it is really low. That means that when the probe is extended out, it's going to trigger before the nozzle gets remotely close to the bed. You want the nozzle to get as close to the bed without actually hitting the bed before it triggers the probe. And once you get that, then we can move on to the next step. Now the next part, and remember that we got the printer set to live move, so go ahead and move your Z back up, and I'm gonna disable the live move, and I'm gonna home the printer. All right, so in this step, what you want to do is, if you're starting from a fresh firmware, then you don't need to do this step because you're not gonna have a bed mesh currently loaded. But if you have a bed mesh and you're having problems with your bed mesh, for whatever reason they're not accurate and your prints are not sticking to the bed and they're lifting and you're having problems, let's view the current mesh. So you go to your advanced mesh leveling, scroll down to view mesh. Let's turn the light off. So this is the current mesh that I have loaded in the printer at the moment. And what we're going to do is we're going to zero out this mesh. To do that, we're going to use a G-code file that I'll have linked in the video description. And thanks Doug O'Connor for giving me the G-code needed to reset the bed mesh. Click on your SD card. And what I did is I created a folder called utilities so I don't accidentally erase my bed mesh. And I have the reset mesh G-code file stored in here. So I'm going to go to reset mesh. It's going to behave just like a print. It's going to start like it's printing, but then it ends, okay? And then you want to click continue. And now let's verify that our mesh is now zeroed out. So we're going to go back to advanced mesh leveling. Go down to view mesh. And there it is. It's all zero. Once you're here, you want to make sure you save this. So I'm going to go back and I'm going to save bed mesh. Another thing that I'm going to do is I'm going to set my probe offset to 0. I'm going to click on probe settings, set my Z offset to 0. Go back. Again, store settings. Go back. And what you're going to do now is you're going to power down your printer. And this step is important because it will ensure that any residual data that's stored in the EEPROM is erased. We don't want any mesh data at all in the EEPROM. So we're going to shut it down. And I like to count to about 15 seconds and then turn it back on. It's about 15 seconds. Let's switch it back on. Again, we're going to verify that there's no bed mesh loaded. Advanced, mesh leveling, view mesh, and yep, we're still zeroed out. Now at this point, you want to make sure that all of your mesh parameters are set correctly. We're going to create a 9x9 mesh. We're going to create a 9x9 mesh, which is the max. Mesh inset. Now, if your gantry hasn't been modified, your mesh minimum is probably going to be like 25 millimeters. So don't change it unless you've made gantry mods that I've made to this printer, and you can see videos on how I did that in my YouTube channel. Click back. I print with PET G at 80C, so that's my bed temperature. Make sure that you set that to whatever temperature you normally print at. Fade height, you can leave at 10 millimeters. And then auto build mesh. Now before I build the mesh, I'm going to warm up my bed. It'll warm the bed up for you, but if the print head is not in a good spot, I like to move my print head off away from the bed while it's warming the bed up. I'm going to move this up about 30 millimeters. I'm going to go back to the main menu. I'm going to go to control. And in control, I'm going to head over to temperature. And I'm going to set the bed at 80. Head back to the main menu. And select prepare. And you want to auto build the bed mesh. All right, now that the mesh is complete, you want to save it. And just scroll over, save. What we're going to do in this step is to set the Z offset. What I recommend is that you pick up a 0.25 feeler gauge. And I used to recommend a 0.15 feeler gauge, but I've found that 0.25 will get you exactly to where you need to be on your Z offset with very minimal adjustment after that. So I'm going to set my Z offset using this 0.25 feeler gauge. To do that, you're going to go to the main menu. From the main menu, you're going to select prepare. You're going to scroll down to where it says Z Probe Wizard. And you want to move Z to home. Okay, the current Z offset right now is 0. So we're going to put our 0.25 feeler gauge under the nozzle. And we're going to start to lower. I'm going to start to lower it using the probe Z offset. And to lower it, it's going to be a negative number. If you notice here, we have negative numbers, and we're going to just continue to lower it until it makes contact with the feeler gauge. So I'm just going to lower it a little bit at a time. And right there, it's barely making contact with the feeler gauge. So I'm going to try it right there. I'm going to save this. And then make sure that you go back again, and from the control menu, store your settings. So let's go back, and now let's try a test print. And all this is a single square, but there are some changes that need to be made in Cura. So let me jump over to Cura real quick, and I'll show you what you need to do. Before we initiate our print, we need to make a couple of changes in Cura. So if you go back to the checklist over here in the 11th instruction, we're going to open the Z offset 2-layer test square, and I'll provide this along with the other files in the video description. And in Cura, we're going to make some changes. In the materials section, we're going to change the skirt brim prime tower and initial flow rates to 120%. So let's do that. Open up your settings, and we're going to look for materials. And these are the 3 settings that you want to change right here. So you have skirt brim flow, prime tower flow, and initial layer flow. The reason we're making this change here is because we want the Z offset to be as high as it can be without having layer adhesion issues. But the challenge with that is dealing with the first layer, because unlike the following layers, the first layer is the only one that needs to be squished a certain amount to be able to stick to the build plate. So that's the reason why we're increasing the flow rate 20% higher than normal. This will give us more material in the first layer, allowing us to deposit that material a little bit higher off the build plate than is needed on layers that follow. So this is very important that you set this, otherwise you're not going to be able to minimize stringing. All right, next thing we're going to do is head over to build plate adhesion, and in here we're going to set this to brim, and then you want a brim distance of 0.2. And the reason that we want this 0.2 is that we want this gap built into our brim, and this is going to help us fine tune the amount of squish to get the perfect first layer. If the brim, for example, is fused to the part and will not come off, then you know that the Z offset is set too low. We have too much squish. If the brim, there's a noticeable gap between the brim and the part, then we know the Z offset is too high. The idea here is to have the brim make contact with the part, but only slightly. You don't want it fused to the part, so that if the brim is easy to remove, then you know you're spot on. So let's go ahead and slice this. Let's check the preview mode. Okay, there's our part. There's our brim. And there's another thing too. If for whatever reason you're not getting a time on your test part here, and that's because there might be a setting that you might need to change. So in the experimental section, I'm using Cura 4.1, 3.1, but if you're using another version, it may or may not still be in the experimental slot. But there's a field here called slicing tolerance, and if this is not set to middle, this part will not slice. For example, if I set it to exclusive, which is good to use if you're dealing with threaded parts, and I try to slice it, I get 0 minutes, and there's an error here. There's no way to slice it. There's no preview, and that's because this setting needs to be set to middle. So now if we slice it again, and now I'm going to save it to SD card. Let's head over to the printer and print it. Print is done. Let's check it out. And the next thing that we want to check and see if the brim is easy to remove. Yeah. Perfect. So that's the perfect amount of squish right there. Lastly, what you can do is print a stringing tower. So let's print that next. Let me show you here. So media. So this is a string tower that has a bridge. So we can test both bridge and string. And it's compatible with the Cura temperature tower profile. So if you load the temperature tower profile, it has segments that I'll show you in the finished print that can be used to figure out what's the best temperature. So let's print it. Alright, just finished. Let's check it out. Yeah, it's a super clean print. And what worked best for me was printing at 215. So I'm not sure. I think Sunlu must have changed something in their formulation because I normally print with their filament at 230. But this latest batch is 215. It seems to like 215 a lot better than 230. If you guys are new to the channel, consider subscribing. Turn on your notification bell. And leave some comments if you have any other questions about Z offset or anything that you saw in this video. Just let me know and I'll do my best to respond as soon as I see them. Alright guys, this video's a wrap. Till the next one. Take care.